students, today we're going to look at how we graph inequalities on a number line. So that is our main objective. But before we get into graphing inequalities, let's look at what inequalities actually are. So if you see the picture that I have here, I have a picture of an equation. It's a scale balance, and with equations they need to stay balanced, so we use an equal sign to show that they're balanced. So this equation, there's only one number. There's only one number that would keep this scale balanced. So if I had, we'll say this is negative x minus 3 is equal to negative 7. I'm going to add 3 to both sides, so I'm just solving the equation like we did in the last part of our unit. And then x is equal to negative 4. So there is only one solution, and the solution is negative 4. Negative 4 is the only number that we could substitute for x for this to stay balanced. Okay, now that we've looked at an equation, let's take a look at an inequality. This example shows an inequality. You can see that the difference between the two scales is this scale is not balanced. You can see that what we have on the left is less heavy than what we have on the right. So this is an example of an inequality because these two sides are not equal. So in order for an inequality to be solved, we will solve it just like we do an equation. The only difference is there's going to be more than one solution. So in order for this to stay true, we could have more than one solution. So again, we're going to solve it similar to how we did the equation, but this time we've got to think about if this side is lighter than this side, that means x minus 3 is going to be less than 7. So we put our line down like we did before. If we add 3 to both sides, this cancels out, and x is going to be less than negative 4. So notice the difference here. This is saying that any number that's less than negative 4, any number that's less than negative 4 could be a solution and keep that statement true. Let's say I had negative 5. If I have negative 5, that would work because it's also less than negative 4. Negative 6 would also work because it's also less than negative 4. So the difference, the main difference here is that inequalities have multiple solutions. Okay, now that we've explored the difference between equations and inequalities, let's take a look at how we will graph inequalities. So our goal for this unit is not only to solve 1- and 2-step linear equalities, but also to graph them on a number line. Let's take a look at a few examples. These are 4 different inequalities. We have x is less than 2, x is greater than 2, x is less than or equal to 2, and x is greater than or equal to 2. Let's start with the first example. So let's think about what this means. If I have a number on the left and this symbol, what that means is that the number is going to be less than. Or another word we use for less would be fewer than. So when we look for numbers that are fewer than, that means it can't be 2. It's only going to include numbers that are less than 2. Let's go first to our graph. Let's go down here. So if I were to graph this, that would mean that all the numbers that are less than 2 are going to be solutions to this inequality. So all of these numbers. Now, because it cannot be 2, we're going to use an open circle. So our circle here would be open circle. So now that we see it graphed on a number line, that's going to make it easy for us to come up with possible solutions that would make that inequality true. 2 is not a solution. 1.5 would be a solution. 0 would be a solution. -3 would be a solution. These are all possible solutions because those numbers are all less than +2. Let's take a look at our next example. This time, the symbol is open. We have the X, and then we have that symbol open towards the X, and then we have a 2 on the other side. This symbol means greater than. So this means greater than. And you may also see it as is more than. If we were to graph numbers that are greater than 2, I would make my line to show any number in the number line that's greater than 2. And again, I'm going to use my open circle. I'm going to use my open circle because it only is true for values that are greater than 2 and not 2 itself. So far we've looked at 2 examples where we would use an open circle when graphing on the number line. Let's also take a look at what would be possible solutions by looking at our number line. So numbers that are greater than would be 2.5, 3, 6, and many other numbers as well. Now let's take a look at our other examples. Now notice that this symbol has a line underneath it. That line underneath it means that it is not only less than, but it also could be equal to. Other phrases you might see for this inequality would be if something is at most that amount or is no more than that amount. So let's look at how we would graph it. If we're looking for numbers that are less than or equal to 2, on our graph, the number could be 2, so I'm going to fill this in, or anything less than that. So for this one, we're going to use a closed circle. So possible solutions for this one would include the number 2. Because 2 is less than, that means 2 is equal to 2, it matches the inequality sign less than or equal to 2. 1 would be a possible solution. -3 would be a possible solution. Any number that's to the left of 2, including 2. The last example that we have here is similar, but instead we have the symbol is opening up towards the X. So instead of less than or equal to, this is going to be greater than or equal to, or at least this amount. So my circle for this one is also going to be closed because it says greater than or equal to. So I'm going to close my circle at the 2, and this time though I'm going to go to the right because it's greater than. I can use my number line to come up with possible solutions. Possible solutions to this inequality include 2, include 3, include 6. Many possible solutions. Okay, that's how you graph inequalities on a number line.